Yesterday we tried some problems on, I should not have used the word yesterday, okay. Problems on substitution method, integration by substitution, we will be continuing. Let me consider integration of 1 by 2x plus 1, a linear function, multiplied by root of another linear function, any linear function you may consider. There I have written x plus 1, I will choose 3x minus 4. Method will be the same. Notice that the integrand is of a particular form, numerator 1 or any constant, in denominator you have a product, one is a linear expression, another is root of a linear expression. My method will be a substitution which helps me in the rationalization of this factor. Let us put 3x minus 4 equal to t square. As a result of this, the replacement for dx is given by 3 dx equal to 2t dt. On applying the substitution, my integral becomes 2t dt by 3 dx. 2x plus 1 is 2 into t square plus 4 by 3 plus 1, t square plus 4 by 3 is x, to be multiplied by root of 3x minus 4 is t. You find that a t is common to numerator and denominator. Some simplification you are able to perform and the integrand becomes 3 denominator 3 cancel, numerator t, denominator t cancel, leaving 2 dt divided by how much? 2t square plus 8 plus 1, 9 I think. Am I right? Yes, I think. Standard function. It's not 8 plus 1, it's 8 plus 3. Okay. Right, you are right. Function to be integrated has attained a standard form. It is in the form constant by x square plus a square, where a is another constant. Taking the help of a standard result, I find the integral as 1 by a root 11 by 2 tan inverse t by a. My t is root of 3x minus 4 by a root 11 by 2 plus a constant of integration. Integration job is finished. Okay, I applied the method substitution 3x minus 4 equal to t square because I wanted this factor to be rational. I wanted the denominator to be a simpler function. I used this substitution. Can I take the help of the same substitution in the next case also? Yes, I can do. With a similar substitution, I can try integration of this also, even when your integrand is of a different form. It is a quadratic function. Multiplied by square root of a linear expression, any linear expression you may consider. The integration is easily performable with a similar substitution, in this case 2x plus 1 equal to t square. One second, break back. Is a substitution of this kind helpful only in situations of this form? No, we can find more problems, more functions, similar functions, but of different form, where still you can work with a similar substitution. For example, let me consider a quadratic multiplied by root of a linear expression. The substitution which helps me in simplifying the integrand will be, as before, linear equal to square of a new variable. On applying the substitution, my function becomes, my integrand becomes this is 2 into x square plus 3 into x plus 1. This is root of 2x plus 1 replaced by a function in terms of t, and this is equivalent of dx. On simplifying, I find the integrand as which is same as am I right? I think so. Integration is straightforward, most straightforward. Term by term integration gives you the answer. There are more situations where similar substitution can be made use of. For example, you may have reciprocal of a quadratic multiplied by root of a linear. Even now you can work with the substitution, this linear equal to t square, provided the job becomes simpler, provided this quadratic is factorizable, in which case you can use the idea of partial fractions to finish the job. Okay. Next case will be, you will have the radical containing not linear instead of quadratic, and the outside function instead of being quadratic is linear now. It is a linear function multiplied by root of a quadratic. One second, break. As next example, let me consider a reciprocal of linear multiplied by root of a quadratic. Any kind of linear expression, root of any quadratic expression of your choice, factorizable, non-factorizable, anything is okay for me. The method I will adopt now will be a substitution for this linear expression. At the outset, it may not be clear how this substitution going to help us in simplifying the integrand. Only by your experience you can infer that when the integrand is of this form, the substitution linear equal to 1 by t will be of use for you. Let me just try the substitution. I am substituting 2x minus 3 equal to 1 by t. Let me check what happens. As a result of this substitution, my integral becomes, is this 1 by t square? Yes. Right, I think. Yes. Divided by 2x minus 3 is 1 by t, root of x square 1 by how much? 1 by 2 of 1 by t plus 3 plus 2 into x is half of 1 by t plus 3 plus 5. I think I have not gone wrong anywhere. On simplifying, let me write the constant factor in numerator outside, bring the t square from numerator to denominator, this t will cancel, 1 t will remain outside, I will shift it inside to become t square, on simplification my expression becomes this minus half was written outside from 1 by t square, and this 1 by t, common 1 by t has removed. 1 t will get shifted to denominator, inside it becomes t square, expansion, denominator 4, this is 1 by t square plus 9 plus 6 by t, each term is multiplied by t square, gives you 1 plus 9 t square plus 6t, here 2 cancel. This thing is to be multiplied by t square, becomes t plus 3t square. This is multiplied by t square is 5t square. This is to get little bit more simplification. I will throughout multiply this by 4, so that nowhere you find fractional coefficients. As a result, this gets affected. This becomes minus. I am multiplying this by 4. To balance that, I will have to divide it outside by 4, not 4, root 4, that is 2, and therefore the coefficient outside becomes 1. Okay. Integral dx by root of 9t square plus 12t square plus 20t square. Is it 41t square? 9 plus 12 plus 20, then 6t plus 4t, then constant term, only term is 1. What you have obtained is reciprocal of square root of a quadratic, a very standard expression, an expression of the form 1 by root ax square plus bx plus c. We have solved enough number of examples of this kind. Method will be completing squares. Before that, if you want, you can make this t square coefficient 1 and then proceed to completing squares method. You know how to finish off the job. I leave it to you. My next example, which has a power of a linear outside a root of quadratic in the denominator, also is solvable by the same method. Even when the index is 3 for the linear factor outside, the problem is solvable by a similar substitution. All the 3 cases come under the same substitution type, the substitution linear equal to 1 by t. Let me explicitly show how this substitution works in the remaining 2 cases. Any linear you may have outside, any quadratic may be inside. Just for a change, I am changing the coefficients. The substitution to be made use of, similar to the previous one, not exactly same, similar to the previous. I will apply the substitution 1 by 3, x minus 3 equal to 1 by 3. As a result, the replacement I get for dx is minus 1 by t square dt. The integrand becomes minus 1 by t square dt. X minus 3 whole square is 1 by t square into root of x square is 1 by t plus 3 whole square, 1 by t square plus 9 minus 6 by t, x is 1 by t plus 3 plus 1. Simplification gives minus of integral dt by 1 by t square gets cancelled, only the expression under the radical sign need be written. When you simplify it, you will get a t in numerator and denominator root of 9 plus 3 plus 1, 13 t square minus 6 by t, plus 1 by t minus 5 by t into t square is minus 5t plus 1. Again, the expression has attained a standard form. You have a linear in numerator, root of a quadratic in denominator. You know how to finish the job. You will first write the numerator as derivative of the quadratic under the radical sign in denominator plus another constant. Break the integrand into two parts and apply different procedures for the two parts to finish off the job. Minus integral of derivative of the quadratic inside under the radical sign in denominator 2060 minus 5. Your requirement is just 1t. Now the constant term gets affected, becomes minus 5 by 6. Your requirement is 0 divided by root of 13t square minus 5t plus 1 dt. This is minus 1 by 26 into 2060 minus 5 dt by root of 13t square minus 5t plus 1 is nothing but dy divided by root of y, or y to the power minus half dy. Integral y to the power half by half 2 root y is 2 root 13t square minus 5t plus 1 plus the other part minus of 5 by 26 into now the function to be integrated is reciprocal of square root of a quadratic. Method will be method of completing squares, but before applying that method, let me make the t square coefficient 1. The quadratic becomes t square minus 5t by 13 plus 1 by 13. On applying method of completing squares, I get first term as it is, second term plus some adjustment needed to obtain the constant as 1 by 13. Agreeable? A little bit of numerical computation is needed to simplify this. I do not know whether I get a constant of the form plus a square or minus a square. It depends on the actual magnitude of this negative quantity. Depending on whether you get plus a square or minus a square, you use a relevant formula and get the function integrated. I think this will be very small number. Therefore, plus 1 by 13 will be of the form plus a square. Integrand becomes 1 by root of x square plus a square, where x is this expression. Integral will be inverse of some hyperbolic function. I will leave it to you to finish the job. As next example, I will consider reciprocal of cube of a linear multiplied by square root of a quadratic. Okay, let this be the integrand. Again, the method that I am going to apply will be similar to the one adopted in the previous two examples. Linear to be replaced by reciprocal of new variable. As a result, our integral becomes minus 1 by t square dt divided by x plus 1 whole cube is 1 by t cube into square root of x square 1 by t minus 1 whole square 1 by t square minus 2 by t plus 1 minus x minus 1 by t plus 1 plus 1. On simplification, I am getting negative of dt by 1 by t square has been removed, 1 t remains. When you simplify this, taking common denominator, you get another t in the denominator of denominator. Those two remaining t's together, t square, will be shifted to numerator, and by denominator will be square root of 1 plus 1 plus 1, 3t square, minus 2 by t, minus 1 by t, minus 3 by t into t square is minus 3t. Then 1 by t square into 1 is 1. You have obtained a quadratic in numerator, square root of a quadratic in denominator. Method well known. You will first write the numerator in a convenient form, in a form suitable to perform division by the quadratic in denominator, so that I can apply the technique of decomposition. I will get this decomposed into 3 parts. In part 1, numerator will be a quadratic which can be easily divided by this. In the second part, numerator will be derivative of the quadratic inside the radical sign in denominator. In the third part, numerator will be a simple constant. So, the adjustments needed. I have taken care of the t square in numerator. As a result of insertion of these two unwanted terms, I have got two unwanted terms in the numerator. They are minus t and plus 1 by 3. I must get rid of these two. Minus, let me write. This is the derivative of the quadratic under the radical sign in denominator. I was supposed to remove only 1t. Okay, I was not supposed to remove, instead I was supposed to add. This unwanted t goes now. The constant finally becomes 1 by 3 minus 3 by 6 is half. 1 by 3 minus half. Is it minus 1 by 6? Yes. We are not supposed to retain any constant in numerator. Everything has been taken care of. Numerator is exactly t square written in a different form. Denominator remains without any change. Perform divisions and carry out integration. You will get minus 1/3 of, minus 1/3 of, this is root 3t square minus 3t plus 1 dt plus next is 1 minus of 1/6 of derivative of quadratic under the radical sign in denominator dt divided by root of 3t square minus 3t plus 1. I think I can carry out the integration now itself. It is of the form dy by root y to the power minus half dy, integral is y power half by half to root y is 2 into root of 3t square minus 3t plus 1, and the last term minus of 1 by 6 into integration of, I forgot to write dt. Please do not follow my mistakes when you write answers in the examination or practice working problems on your own at home. So, without this dt, the expression becomes a meaningless expression. You have to, without forgetting, you have to write this differential before passing on to the next step. My next term is integration of dt by, let me prepare myself to get the function integrated. I will first make the coefficient of t square under the radical sign 1. It becomes root 3 into root of t square minus t plus 1 by 3. Now, to get this integrated, the method is you have to bring this integrand to a standard form. The standard forms of which are relevant now are root of x square minus a square, root of x square plus a square, and root of a square minus x square. This will be brought to one of those three forms. You may write this as taking root 3 outside, t minus t square minus t plus 1 by 3 is one by 4 plus what gives me 1 by 3, or let me write 1 by 3 minus 1 by 4, no problem. Root 3 has been taken out. It becomes t square minus t plus 1 by 3. On applying completing squares, t minus half whole square, I get t square minus t plus 1 by 4 removed plus 1 by 3 added. Okay, remaining things as they are. I am copying the expressions as they are. Each integrand has been obtained in a particular standard form. This is in the form root of x square plus a square, and this is in the form 1 by root of x square plus a square. You know what is integral of root x square plus a square. You also know what is the integral of 1 by root x square plus a square. Simply apply the standard results, get the integration performed. If possible, carry out some simplification to obtain the answer in a neat form. Okay. My next function for integration will be a function of the form 1 by some ax square plus b into root of cx square plus b. A, b, c, d may be any constants. Notice that this is not an arbitrary quadratic, this is a quadratic with the x term missing. This also is a quadratic with the x term missing. If x terms occur either here or here, the method I am going to explain will not work, will fail. Only when my integrand is of this form, a usable substitution is x equal to 1 by t. Not this whole thing equal to 1 by t as we did in our previous case, or this equal to t square as we did in one of our earlier examples. Totally different substitution, x equal to 1 by t. As a result, my integrand becomes minus 1 by t square divided by a by x square is t square plus b into root of c by t square plus d. On simplifying, what I get will be negative of dt by root of a plus bt square into root of c plus dt square. One extra t we will be getting in denominator. Let us shift it to numerator. Are you familiar with this kind of situation? Yes, is workable. How? Simply apply a substitution for this quadratic under the radical sign. The substitution which may help you because of the presence of this t. It looks very similar to our original function, but there is a major difference between the two. In the original case, we had a quadratic multiplied by another square root of a quadratic in denominator. Numerator was just dx. Now you have an extra t in numerator with dt. That is of great help to us. We can take the help of this using the substitution c plus dt square equal to y square. Equivalent expression for dx dt is what is that I have written? Okay, I got confused with the dt and dt square. This is not square of dt, it is a constant d multiplied by t square. So result for differential will be 2d into 2t dt equal to 2y dy. Okay. My integral becomes okay, 2 is extra. It is d into 2t dt equal to 2y dy. Integral becomes minus of t dt is y dy divided by d don't try cancellation of this d against this d. Denominator a plus bt square is a plus b into t square. T square is y square minus c by d into root of c plus dt square is simply y. This y gets cancelled against this y in denominator. The numerator becomes a constant. Denominator becomes a simple quadratic. On simplification, you will be getting something of the form some constant into y square minus or plus, I am not sure. It depends on the magnitudes of ABC. A constant times y square plus or minus another constant square. Whatever be the form of the function, it is easily integrable with the help of a standard result. I have not assigned any particular values for ABC and ABCD. I have considered the general case itself, and I think the procedure explains how you have to work even when ABCD numerical values are provided to you. Okay. One more extension of the same method, slightly more complicated function I will consider. I will have exact values for the coefficients, some numerical example. I will have a cubic in numerator. Denominator will be of the same form. Okay. This is the integration I am required to carry out. I think there may not be any substitution which directly gets the integrand simplified to a standard form. We will have to work out a bit more before applying or before thinking of applying any substitution. What I do is first separate the odd degree terms from numerator, separate them from even degree terms. Write this as 3x cube minus 2x divided by x square plus 4 into root of x square plus 1 dx. These are separated from even degree terms. So, the other part x square plus 1 divided by x square plus 4 into root of x square plus 1 dx. We will follow one procedure to get this integrated, a different procedure to get this integrated. In this case, the method you may conveniently make use of is a simple substitution, a substitution like x square equal to t, or if you want a still better substitution, a substitution which not only takes care of the odd powers of x in numerator, but also this irrational factor. You may use x square plus 1 equal to y square. And in this case, let us think of that later separately. Let me handle the two integrals one by one individually. First integral method I have already told you will be use of the substitution x square plus 1 equal to y square. The integral will become root x square plus 1 is y, x square plus 4 is y square minus 1 plus 4, y square plus 3. Numerator, one x is common there. When you write that x outside is 3x square minus 2, 3 into x square is y square minus 1, minus 2 into I am having x dx, which according to this statement is y dy. Y cancel, leaving 3y square minus 3 minus 2 minus 5 divided by y square plus 3 dy. A very simple situation. We write this as integral of 3 plus, how did I get 3? Dividing this 3y square minus 5 by y square plus 3, I will get a term in the quotient as 3. The remainder that I get on division will be minus 14, I think I am right, divided by y square plus 3 to take care of that remainder term dy. Integral is 3 into y is root of x square plus 1 minus 14 into integral of 1 by y square plus 3, 1 by root 3 into tan inverse of y by root 3, y is root of x square plus 1 divided by root 3, constant we will add at the end. This is only a part of the required integral. Let me keep it like this. Okay. Now we have to take care of the second part, which is integral x square plus 1 divided by x square plus 4 into root of x square plus 1. Actually, one coincidence has taken place here. This was not anticipated actually in advance. Okay, I should have seen it here itself. I didn't see it. We find 1 root x square plus 1 common to numerator and denominator. We can think of cancelling that. But if we cancel that, we will be left with root x square plus 1 by x square plus 4. How will you provide a method for simplifying this integrand? Does it work? Can it be simplified with a substitution? Yes. As a next example, I will be considering a cubic, an arbitrarily chosen cubic, divided by an expression of the form ax square plus b into root of cx square plus d, where a, b, c, d are constants. Let me have a, b, c, d specifically chosen. Okay, let me consider this. I don't think there is any proper substitution with the help of which I can directly bring this to a standard form, or directly bring it to a form which is easily, immediately integrable. Some manipulation will be needed before applying any of the techniques. What I do is separate the odd degree terms in numerator from those terms having degree even. I will write this integral as 2x cube plus 5x divided by x square plus 1 into root of x square plus 3 part 1 plus 1 minus 3x square divided by x square plus 1 into root of x square plus 3 part 2. The two parts will be separately handled. This will be handled separately, applying a certain procedure, and this will be treated separately, applying another totally different procedure. Let me consider the two integrals separately. First, integral 2x cube plus 5x divided by x square plus 1 into square root of x square plus 3. The method I am going to apply now will be substitution. Substitution that will take care of two things. One, the presence of odd powers in numerator, also simultaneously this irrationality of one of the factors in denominator. I will go for substitution x square plus 3 equal to y square. As a result, the integral becomes root x square plus 3 is y, x square plus 1 is y square minus 3 plus 1 y square minus 2. In numerator, let me break this. Let me treat this as 2x square plus 5 multiplied by x. 2x square plus 5 according to this will be 2y square minus 1. 2y square is 2x square plus 6. 2x square plus 5 will be 1 subtracted from that into x dx is nothing but y dy. On cancellation, this becomes 2y square minus 1 divided by y square minus 2. A rational algebraic fraction which is not proper but improper, having degree of numerator equal to degree of denominator. So, the standard approach, first we will perform division. Write the integral as integral of 2 plus. To perform division by 2, I need the numerator as 2y square minus 4. 2y square minus 4 divided by y square minus 2 gives me the quotient part 2. But writing this as 2y square minus 4 changes the numerator in the size of the constant term. Adjustment, you add 3. This happens to the integrand. On integration, I am getting 2y, 2 into square root of x square plus 3 into integral of 1 by y square minus 2, use of a standard result, 1 by 2a log of modulus of y minus a, y is root x square plus 3 minus a root 2 divided by y plus a root x square plus 3 plus root 2 plus an arbitrary constant which need not be included at this stage. What you have obtained is only a part of the required integral. Final integral, the integral you are supposed to obtain is different, this is only a part of it. So, constant will be added only at the end. Part 1 is over, integration of one of the parts is 2 parts is finished. Now, let me take up the second part. The second part is integration of 1 minus 3x square divided by x square plus 1 into root of x square plus 3. As it is not in any standard form. As it is not in a easily reducible form. But I can bring it to a simpler form. How? Let me treat the numerator as minus 3x square minus 3, so that portion together with this portion will have a common factor and adjust the constant term. So, what I am doing is write the numerator as minus 3x square minus 3 plus 4, denominator no change, break the integrand, this portion divided by this denominator will be minus 3 by root of x square plus 3. The other part is 4 divided by x square plus 1 into root of x square plus 3 dx. This integration straightforward, direct use of a formula. This integration you are already made familiar with. The method will be substitution, x equal to 1 by t. We have already tried 1 or 2 problems of that type. I leave this job to you. Finish the integrations, add what you obtain as integral to this portion, a part of the integral which has already been obtained. To the result, add a constant of integration. What you have obtained will be the final answer, the integral that you are required to obtain. As next example, just for a change, let me consider a simpler situation. Suppose your integrand is a fraction with a constant in numerator, just one irrational term in denominator. You know how to handle the situation. Very simple, direct application of a standard result. Suppose now, just to make the situation slightly more complicated, I will add one more irrational term to the denominator. Now the integration is not immediate. It is not immediately obtainable with the help of a standard result, but we can bring the integrand to a simpler form taking the help of a substitution. Substitution you need will be chosen in such a way that both these irrationals become rational. Convenient substitution may be x equal to t to the power 6 or x equal to t to the power 12 if you desire, or x equal to t to the power 18, any common multiple of 3 and 6. Easiest one, the smallest one is 6. The integral will take the form dx is 6 t to the power 5 dt, denominator cube root of x is t square, sixth root of x is t. Some common things are there, remove them, you will be left with t to the power 4 by t plus 1 dt. Successfully you have reduced your integrand to a rational algebraic fraction, but the fraction is not proper, it is improper. Bring it to proper form, integration will become immediate. Next, let me consider, instead of taking cube root and sixth root together, suppose I consider cube root and fourth root together, what happens? Or let me have a simpler case, cube root and square root together. Again, substitution to be used, very similar to the one used in the previous example. You choose a common multiple of 3 and 2, the orders of the two irrational terms in denominator. Any convenient power t raised to that common multiple will be helping you in simplifying the integrand. Integral has taken the form 6t to the power 5 divided by cube root x is t square and square root x is t cube. Again we find certain things common to numerator and denominator. On removal of those common factors, you are getting 6 into integral t to the power 3 divided by 1 plus t square dt. Again we find the integrand in a rational algebraic form which is not proper. To bring it to proper form, perform division. Immediately we will get it as a polynomial of degree 1 plus a proper fraction, both parts easily integrable. In our next problem, we will have a biquadratic in denominator, not an arbitrarily chosen biquadratic. It will be considerably simple biquadratic. It will have a term containing x power 4. It will have a constant term. It may or may not have a term with power 2, but it will not have a x term or x cube term. A general form of the biquadratic in denominator will be ax to the power 4 plus bx square plus c. Together with that, in numerator I will have a quadratic. Most general form, not ax square plus bx plus c. I will be choosing only a quadratic of the form ax square plus b. There will be no x term in numerator. To start with, let me have a simpler expression both in numerator, simpler expressions in both numerator and denominator. Let denominator be x to the power 4 plus 3 and numerator be say x square, simply x square. How to get this integrated? If the numerator were x cube, the process would have been very simple. You would have tried the substitution x power 4 plus 3 equal to t. If the numerator is just a x, then also it would have not been difficult. You could have tried the substitution x square equal to t. Now we are having neither x cube nor x in numerator, instead we are having x square. What I do will be divide numerator and denominator both by x square and obtain the integrand as this. Has not complicated the situation. We are actually directed towards simplifying the integrand. We are preparing ourselves to take the help of a substitution to effect simplification of this integrand. What I do will be, I see that this denominator is expressible in terms of any of the two, x plus or minus root 3 by x. If you are using x plus root 3 by x, denominator is expressible as x plus root 3 by x whole square minus a constant. The constant to be subtracted is root 3. Using x minus root 3 by x, you may write it as x minus root 3 by x whole square plus root 3. You can write the denominator in any one of these two forms. But to use this form in carrying out integration, I need derivative of this in numerator. And to use this form in the denominator, your objective is to carry out integration. Don't forget that you will require derivative of this in numerator. What is derivative of this? Derivative of this is 1 minus, I am not taking into consideration the square, just x plus root 3 by x. Derivative is 1 minus root 3 by x square. And for this part, derivative is 1 plus root 3 by x square. Do you have any one of these two in numerator? No, we are not having neither. We are not having either 1 minus root 3 by x square or 1 plus root 3 by x square. What to do? I will write the numerator as a linear combination of these two. That will be possible for me. What I do is, I write the numerator as half of 1 plus root 3 by x square plus 1 minus root 3 by x square divided by x square plus 3 by x square dx. Decompose the integrand. In one portion, I have taken the numerator as half of 1 plus root 3 by x square. In the other portion, numerator is half of 1 minus root 3 by x square. Actually, in both cases, denominator will be x square plus 3 by x square, but we prefer to have it written in different forms. In the first case, because numerator is 1 plus root 3 by x square is derivative of x minus root 3 by x, I will write the denominator as x minus root 3 by x whole square plus 2 root 3. In the second case, because the numerator 1 minus root 3 by x square is derivative of x plus root 3 by x, I will write the denominator as x plus root 3 by x, this is not 2, x plus root 3 by x minus 2 root 3. Now, this is dt by t square plus a square, where t equal to x minus root 3 by x. This is dy by y square minus a square, where y is x plus root 3 by x. Let me record what I have already told. Numerator is derivative of x minus root 3 by x. Denominator is x minus root 3 by x square plus 2 root 3. In the second case, numerator is derivative of x plus root 3 by x and denominator is x plus root 3 by x whole square here is a square, minus 2 root 3. This is half of dy by y square plus a square, integral of which is 1 by a tan inverse y by a. This is integration of half of dy by or dt by t square minus a square, integral of which is 1 by 2a log t minus a by t plus a. My integral is half of 1 by a root of 12, this is a square, so a is 4th root of 12, a square is root 12, a is 4th root of 12, tan inverse y by a, y is x minus root 3 by x divided by a is 4th root 12 plus half of, this is dt by t square minus a square, 1 by 2a, 1 by 2 into a 4th root of 12 log of mod of t minus a x plus root 3 by x minus a 4th root 12 by t plus a x plus root 3 by x plus 4th root 12. Integration process is complete. Don't forget to add the constant of integration. If possible, perform whatever simplification is applicable, the answer is obtained. As next illustration, let me consider a slightly more complicated case. As before, denominator will be biquadratic with odd degree terms missing, say x to the power 4 plus 2x square plus 3. Numerator, in order to apply the procedure that I have described in my previous illustration, numerator must be a quadratic with the x term missing. But now I want to handle a slightly more difficult case, more complicated case, not an immediate replica of the previous case. So I will consider a cubic, randomly chosen cubic in numerator. How to handle the situation? What we do will be, we had tried this idea in one of our previous illustrations. We separate from numerator terms of odd degree from those of even degree. As a result, I will have my integral as in the first part, I may think of applying a substitution. I cannot apply a substitution for this whole thing because the derivative of this is not seen in the numerator, but at least for a part of the denominator expression for x square, I can certainly apply substitution. I will use the substitution x square equal to y, which substantially simplifies the form of the integrand here. In this case, the method to be adopted is totally different. It will be similar to the one we employed in the previous example. We will divide numerator and denominator by x square. If necessary, decompose it into various parts and proceed. Let me handle the two situations individually. Consider first 2x cube plus x by x to the power 4 plus 2x square plus 3. What I am going to do now to get the integrand simplified will be use of substitution x square equal to y. As a result, my integral will become, then the integral becomes denominator y square plus 2y plus 3, numerator 2x cube plus x is 2x square plus 1 multiplied by x 2x square plus 1 is 2y plus 1 into x with dx, x dx is dy by 2. Is this a situation already familiar to you? Yes. It is linear divided by a simple quadratic. What will be the method? Express the numerator as derivative of the quadratic in denominator plus or minus a constant. Decompose the integrand such that in one part numerator will be derivative of the denominator, in the other part numerator will be a constant. Part 1 will be integrated by substitution, part 2 will be integrated by method of completing squares. Now coming to the second part. Three x square plus 1 divided by x power 4 plus 2x square plus 3. Procedure already explained once. Divide numerator and denominator by x square to obtain the integrand as 3 plus 1 by x square plus 2 plus 3 by x square. Find out the expressions in which the denominator can be easily expressed. The denominator can be easily expressed in terms of each of x plus or minus root 3 by x. And for these expressions, the derivatives are 1 minus or plus root 3 by x square. Try to obtain the numerator as a linear combination of these two, 1 minus or plus root 3 by x square. It may not be directly seen what linear combination of 1 minus or plus root 3 by x square is going to give you 3 plus 1 by x square. In order to determine that, some numerical calculations may be necessary. Suppose the numerator 3 plus 1 by x square, the expression which is to be obtained, is some constant a into 1 minus root 3 by x square plus another constant b into 1 plus root 3 by x square. If this is valid, then we must have comparing rationally rational term, not comparing rationally rational, comparing terms involving x and not involving x. You get a plus b equal to 3 and minus root 3a plus root 3b must be equal to 1, or a plus b equal to 3 and minus a plus b is equal to 1 by root 3. Solving the two equations, you find simply adding adding you will get b first, adding you will get b as half of 3 plus 1 by root 3. And subtracting one from the other, you will find a as half of 3 minus 1 by root 3. Taking the help of these values, I find the numerator of the integral you are required to obtain as half of 3 minus 1 by root 3 into 1 minus root 3 by x square plus b half of 3 plus 1 by root 3 into 1 plus root 3 by x square. This is the numerator of our integrand, and the denominator as it is without any change for the moment is x square plus 2 plus 3 by x square. Now, taking advantage of what you have obtained in the numerator, we will break the integrand. We will write it as half of 3 minus 1 by root 3 into integral of what you have in numerator now. Notice it is derivative of x plus root 3 by x. When you have obtained numerator as derivative of x plus root 3 by x, it will be convenient to obtain denominator also in terms of this x plus root 3 by x. I will write it as x plus root 3 by x whole square minus 2 root 3 plus required constant. The second part is half of 3 plus 1 by root 3 times integral of the numerator appearing in the second part of the integrand is derivative of x minus root 3 by x. When you find the numerator like this, we prefer to have denominator also expressed in terms of same x minus root 3 by x. We will have it as x minus root 3 by x whole square plus 2 root 3 plus 2. This is half of 3 minus 1 by root 3 into what is the form dt by t square. This is minus a square or plus a square, is minus a square, dt by t square minus a square. The integral is 1 by 2a am I right? Right, I think. I am treating this as minus a square. This is minus of 2 root 3 minus 2. 2 root 3 minus 2 is a positive number. If I write 2 minus 2 root 3, it will be negative. 1 by 2a into log of mod of t x plus root 3 by x minus a root of 2 root 3 minus 2 divided by t x plus root 3 by x plus a root of 2 root 3 minus 2 plus second part half of 3 plus 1 by root 3 into integral of dy by y square plus a square. Integral is 1 by a is square root of 2 root 3 plus 2 into tan inverse of y by a x minus root 3 by x divided by a square root of 2 root 3 plus 2. Job of integration is finished and constant of integration you have obtained your required answer. Simplification if possible.